I want to thank the commissioners from Uinta and Duchesne County for allowing me to make this presentation to you this morning about technology that's not really new, but I would say improved and not really well known, and that is microturbine generators. What I hope to pass along to you today is the following information. What is a microturbine? The benefits of using microturbines, different applications, and then the company that I work for, Horizon Power Systems, and I'll show you some of the applications that we've been able to put microturbines into in the oil and gas business. So the product that I represent is Capstone MicroTurbine. Capstone was taken public in 1998. It was actually started in 1988 out in California and commercially launched in 1998. Headquarters are in Chatsworth, California, which is right next to Hollywood. Sales and service centers around the world, over 90 distribution partners, and then well over 7,000 units have been shipped. And our company, Horizon Power Systems, is Capstone's first and largest distributor. We cover that service territory that is in green. So we have shipped well over 1,100 units and installed those within our territory. We also offer system design, applications engineering, and of course we have a full service staff. So with Horizon Power Systems, I am a senior account manager, which means I am the oldest salesman. But let's start with what is a microturbine. Microturbine is simply a scaled down gas turbine. It's a gas turbine engine with a single shaft that has a compressor, a turbine, and then a magnet on the end, a permanent magnet spinning in a stator. Okay. Electrical efficiencies, 26 to 33%, are pretty close to a reciprocating engine generator. But you can combine this with CHP, which is combined heat and power, and get thermal efficiencies of 80% or better. And I'll explain a little bit of that later. One of the big advantages is we can burn a wide range of fuel, from 350 BTU fuel, which is land gas, landfill gas, all the way through propane. So it's the same unit. We may change out some materials of a fuel valve or something, but it is the same unit. We can also burn fairly high concentrations of H2S, 7% on our smallest unit, a 30 kW unit, but all of the line can now burn up to 5% H2S. Very low emissions, so normally meets air quality requirements right out of the box, no additional equipment required. The unit runs on air bearings. So there's a better explanation in the next slide, but there are no oils or lubricants on the unit, and it's also air cooled, so there are no coolants on the unit. This leads to very long intervals between services and also a very reduced cost of maintenance. They run very fast. The speeds when it's producing power between 45,000 and 96,000 RPM. So one moving part, like I said, we call it the rotating assembly. No, it rides on air bearings again, and it's a spring and foil type air bearing. I guess the best way to explain it, if you're playing cards and you slide a card across a table, a flat table, and it kind of glides across on that little cushion of air, that's the same thing, same type system that these air bearings work on. When the unit starts, within 2.5 seconds, that shaft is up and off the air bearings and riding on that cushion of air. So there's a picture of the engine. You have air intake. It is a recuperative turbine, so it is using a heat exchanger. You bring fresh air in, mix it with fuel, ignite the fuel, you start a combustion, a continuous combustion, spin the turbine, and you spin the magnet within a stator at a very high speed. So you're producing a variable voltage, variable frequency power with that magnet spinning in that stator at that high speed. The units are inverter based, so using inverters, VFDs essentially, you bring that power from an AC to a DC bus, back to an AC, through the inverter, and it comes out as a utility grade, very clean 480 volt three-phase power. Capstone offers 3 sizes of engines, essentially. There's a smallest one, a 30 kW unit. Applications, cathodic protection. We have a number of these units running very remote locations. They get serviced once a year, and they just go out and they run, and they're usually under a very light load. The 65 kW unit, which can also be purchased with an integral heat exchanger. That's what that little top hat is. And then a 200 kW unit. So the real market, or what Capstone envisions the real market being, is in a larger size unit. And the way they achieve that is by taking 3 to 5 of the 200 kW units, and they're installed in a modified ISO shipping container. So everything's there. The fuel system's in it. It's all electrically wired. You have 3 connections, really. You connect your fuel gas, connect to the power, and then if you need to do something with the exhaust, you can connect to the exhaust system. Any of the Capstone units, you can take multiple units, connect them together with a communications cable, and they'll act as one. We call this multi-packing. And I'll show you an example of a slide where we've done up to 19 different separate units, all connected with communications cable, acting as one, as a power generating station. So benefits, low cost of ownership. Scheduled maintenance on a Capstone turbine is 6 hours or less per year. So that's the time that the turbine should be down for maintenance. Maintenance costs, and Capstone does offer a product where this is kind of a guaranteed cost, is 1.5 cents a kW hour. No lubricants, can produce electricity. This 4 cents a kW based on $4 gas is ISO conditions, so it may be slightly higher at our elevations. It is oil and gas proven. I would say of our 1,100 plus units, 11 or 1,000 of them are in oil and gas applications. Very low emissions, like I said, meet air quality. They're quiet, 65 dBA at 10 meters. That's just in that industrial shell that you're seeing there. A lot of times in harsh, very harsh climates, we'll put them inside a building, and you really can't tell they're running unless you can see the rain cap. And then, like I said, I can burn a wide variety of fuels. So you may have trapped gas, flare gas, coal seam gas. We have run the turbines off all of them. So a few applications in the oil and gas industry, that some of the projects we've done. Down in West Texas, that top picture is 3 C65 units, and they're running a small amine plant down in the Eagle Ford. The bottom picture are some larger units. That's, see, there are 3 stacks, so there are 3 C200s in that unit. So that's a 600 kW unit running, I believe, also in Texas. But again, low maintenance costs. Capstone was also developed, the units were developed so that they could easily be tied into a grid system. So you can use the turbines as a peak shaving device, power sharing device, and also as a backup generator, a running backup generator. Small footprint. Also, when you talk about critical units and you have a redundant, say a big recip, instead of having to buy a full-sized separate generator as a redundant unit, we can simply add one more smaller unit, and it gives you an N+1 redundancy and may save you a whole lot of money and a whole lot of space. One project that I did that was fairly interesting was a remote oil field, coal seam play down in New Mexico. And they wanted to put in a water collection system. They were driving trucks everywhere. And so while they had the ditch open, we put in a power grid, and it was on BLM land. We had to bury the power lines. But we brought in 19, in those buildings, there are 19 Capstone units. Brought them all to a transformer, bumped the power up to 13,000 volts, and then sent it out through their field and connected 35 wells where on location, we used transformers again, step-down transformers, brought it back to 480 volt, ran their water transfer, their artificial lift, or their pumping units, heat trace, and anything else that they needed on those locations. So we took a lot of water trucks off the road. The BLM was happy. We took a lot of maintenance trucks off the road. Again, the BLM was happy. And we reduced their LOE overall on those locations by getting rid of engines that required services every 30 days and having them electrify their pumping units and their water transfer units. This is a saltwater disposal well out also in northern New Mexico. You can see there are 4 units running. 2 of them have heat exchangers on those units. They removed tank heaters from their tanks and used the heat exchangers and pumped a water glycol mix through the tanks and used those to keep their water tanks from freezing, while also providing power for their saltwater disposal unit and other needs on location. The units can run in both a standalone mode, which is like these units are, no grid to connect to, or they can connect to the grid and work in conjunction with the grid. So applications not only in the oil field, but in what we would just call industrial services or commercial services, such as a manufacturing plant where you're starting relatively large motors fairly often, and you have a high peak demand charge. You can have the turbines run, and they can run all the time. They can shave off that peak demand charge. They can also power share, so you're eliminating some of the payments you're making to the utility for electric power. And then if you can use the exhaust heat as part of your process, you can really bring efficiencies up to where your total utility cost for power is much lower. The other thing you can do is you can instantaneously, if you lose the grid, switch over and have the Capstones or the microturbines pick up critical loads so that you keep your plant running. So, microturbines do offer a wide range of power solutions. It's not always the best solution, but would be more than happy to talk to all of you about potential sites and whether or not it is the right solution. We do have a low cost of ownership. I have run them in very harsh conditions, including high elevation, low temp, high temp. We do package completely the systems, so security in buildings, with fuel systems, whatever you need. Horizon Power is owned by the Henry families. We're a privately held company out of Farmington, New Mexico, and have been in the oil and gas business for over 55 years. And so we know the oil and gas business, and we can do a project correctly. I have been dealing with Capstone MicroTurbines. I did sell my first one about 18 years ago. I would say they do have the lion's share of the market in the microturbine business, and they're improving all the time. Well, I appreciate your time. Again, I'd love to talk to any of you about any potential applications. If you'll look at our website, horizonpowersystems.com, my contact information is there, and I appreciate your time again. Thank you.